Hello everyone, welcome to my YouTube channel. Today we will be discussing about the difference between quarter watt, half watt and 1 watt resistors. Resistance is one of the most important terms used in electric circuits. The resistance is measured in units called ohms. Resistance is a term that describes the forces that oppose the flow of electron current in a conductor. All materials naturally contain some resistance to the flow of electron current. The scientific definition of 1 ohm is the amount of electrical resistance that exists in an electrical circuit when 1 amp of current is flowing with 1 volt being applied to the circuit. Let's start the discussions with more details. A resistor is defined as a two-terminal passive component used in electric circuits for reducing the current flow, adjusting signal levels, and to bias the active elements. The reducing the current flow causes loss of electric energy in a form of heat, and if we increase the flow of current the resistance will turn hotter. This term is also known as resistor's power rating. Using the Ohm's law, the resistance of any component is defined as the ratio of voltage applied to the electric current. The theoretical formula of resistance is shown. The Ohm's law states that for many conductors of electricity, the electric current which will flow through them is directly proportional to the voltage applied to them. When a microscopic view of Ohm's law is taken, it is found to depend upon the fact that the drift velocity of charges through the material is proportional to the electric field in the conductor. The ratio of voltage to current is called the resistance, and if the ratio is constant over a wide range of voltages, the material is said to be an ohmic material. We know from Ohm's law that when a current flows through a resistance, a voltage is dropped across it, producing a product which relates to power. In other words, if the resistance is subjected to a voltage, or if it conducts a current, then it will always consume electrical power, and we can superimpose these three quantities of power, voltage and current, into a triangle called a power triangle, with the power, which would be dissipated as heat in the resistor at the top, with the current consumed, and the voltage across it at the bottom as shown. The power triangle shown is great for calculating the power dissipated in a resistor if we know the values of the voltage across it and the current flowing through it. But we can also calculate the power dissipated by a resistance by using Ohm's law. Ohm's law allows us to calculate the power dissipation given the resistance value of the resistor. By using Ohm's law, it is possible to obtain two alternative variations of the above expression for the resistor power if we know the values of only two: the voltage, the current, or the resistance. P in the previous slide is in watts, so if you know the resistance and either the current or the voltage through the resistor, then you can see if you need more power handling THAN1, 0.25 or 0.5, noting that the closer you get to the max power dissipation, the more environmental factors matter: how tight the resistor is with other hot, how much airflow there is, how close it is mounted to the board. The resistor wattage is how much power it can dissipate in free air when the resistor is 25 degrees above ambient. If you are not in free air, then you'll need to derate the resistor and/or live with a shorter lifespan and out of tolerance behavior caused by high temperatures. Depends what you are doing. If you are going to be dissipating more than 1/4 watt, you need to go with the bigger resistor. If it's under 1/4 watt, you can use that one. The 1/4 watt resistor will work for short periods of time at above the rating, but the life will be shortened. If it's something that's constantly in use, it will quickly heat up and probably burn out. Maybe in grand style. Figure shows the four different resistance power of different values of 0.25 W, 0.5 W, 2 W and 11 watts. This figure shows with the increase of power the dimension, or we can say the surface area of resistance, also increases. Resistors are mainly explained by their resistance value and its tolerance electric power, also known as electric power value, in watts. If the size of resistor is more, its surface area can handle more power, and hence for the high watt rated resistors will not easily burn up. We can also say that the lower the value of electric power, the surface area of resistance is lower. In addition, higher the value of electric power, the surface area of resistance is higher. Thank you for watching this video. If you have any questions, please leave a comment below, we will get back to you. If you like this video, please like, comment and share with your friends. And don't forget to subscribe my channel.